Hey guys, today we're going to start chapter 6, which is the beginning of our trig section. This semester will be all trigonometry. Today we're going to focus on a few things that you learned in geometry, plus trying to go a little bit deeper into understanding what those things are that you learned in geometry. So we're going to start with what's called right triangle trig, which means you have a right triangle. So you've got a right angle. The opposite side from the right angle is the hypotenuse. And then you've got two legs. Now, when you're talking about trig, you'll often hear the words opposite and adjacent. There is no such thing as the opposite or adjacent leg of a right triangle. Those words have to do with perspective, and it has to do with what angle you're looking at. So, if this is the angle we're talking about, this little symbol right here is a variable. This is a theta symbol. We like to use x, y's, and z's in algebra, but in trig, we'll use a lot of Greek letters, and that's all that is. So just a circle with a little line through it, that's a theta symbol. So this is the side that is opposite, or like across from, the angle that we're talking about, and this is the side that is adjacent, or next to, the angle that we're talking about. So that's what those two words refer to. In geometry, you learned sine, cosine, and tangent. And what these things are the relationships between two sides of the triangle. So, for example, the sine of an angle refers to the relationship between the opposite side and the hypotenuse. It's a ratio. You take the opposite side, you divide it by the hypotenuse, and that's the sine of the angle. As this angle changes, this ratio is going to change, okay? And that's something you're gonna discover and look at a little bit later, okay? The cosine of an angle is just the relationship between this adjacent side, this length, and the hypotenuse. So adjacent over hypotenuse. And the tangent of an angle is the relationship or the ratio between the opposite side and the adjacent side. Opposite and adjacent. Okay? You need to learn these. Okay? These ratios need to be just something that you know. If I say what's the sine of an angle, you should understand what ratio I'm referring to. There's different ways to learn it. I know a lot of geometry teachers like to use SOHCAHTOA. SOHCAHTOA. To try to get you to remember the order and the way these go together. I simply try to remember these letters out here. I like to think of these as ratios, to think of them as fractions. I don't like them all looking like one word that are all in a line. I just like these letters that are out front. And then you just need some kind of mnemonic device to remember them. So like when I was in high school, it was Oscar has a hat full of apples. And as silly as that is, that was 30-some years ago when I learned that, and I still remember it. So it works. Or the one that my dad taught me, who was not a math teacher, but somehow remembered this from when he was in school, was, oh heck, another hour of algebra. And when you see me write these on the board, that's going through my head as I'm writing them so that I get the letters right. Or you can just remember opposite, hypotenuse, adjacent, hypotenuse, whatever it takes, but you just need to remember those. Okay? Now, if you accessed this document on Schoology, then there is a little hyperlink that you can follow. Okay? So, if not, go to Schoology, go to the Chapter 6 folder that I have, open today's notes, and there's a hyperlink, and I want you to go to that, and when you do, you should get to this website. Okay? And I want you to try to complete this activity on your own as much as you can. What you're going to see is a right triangle. We've got our opposite side. Not sure why that did that. We've got this opposite side that's labeled as y. We've got an adjacent side that's labeled as x, which makes sense. X, y coordinates. Okay? They labeled the hypotenuse as r. We'll talk about that later, some other time. Okay? But that's how they labeled it. I'm going to see if I'm going to be able to move things around. On this, there are a couple things you can do with the triangle. You can change the angle, and you can change the size of the triangle. So this little zoom, if I click on that, I can make it really, really small. I can make it really, really big. Okay, what I want you to do is I want you to pick a size and an angle to start with. Okay, so it doesn't matter what it is. So 23. I chose a 23. I don't know why. Okay, so pick an angle, and then I want you to write down, so if you look at your worksheet, I want you to write down the sine, the cosine, and the tangent that you see. Okay, so write down these numbers on those blanks. And then I want you to just kind of read through and complete the activity. The idea is I want you to change the shape of the triangle. Make it really, really small. Make it really, really big. And I want you to notice what's happening over here. Okay, you'll notice all these values are changing because this is the length of this y side. This is the length of this hypotenuse right here. And as the size of the triangle changes, it changes. But you'll notice that these numbers do not change. So the question is why? So I want you to look at that and see if you can figure that out. And then I also want you to change the angle. I want you to make the angle really, really small. Make it bigger. And again, I want you to take a look at what is happening to these values out here. And then after you've done that and tried to answer these to the best of your ability, I want you to pause the video right now. And then you can unpause it, and I'll kind of explain what you should have been seeing. Okay? Alright, so hopefully what you noticed was, as you change the shape of the triangle, all of the sine, cosine, tangent values were all staying the same. Why? Because as the triangle gets bigger or smaller, the ratios, which is all these values are, they're all going to stay the same. If the triangle doubles in size, then all of the sides are doubling, so the ratio stays the same. Okay, so that's important. Also, what happened as your angle got bigger or smaller? Okay, so as your angle, and I told class, it's actually the easiest one to probably look at first is probably the tangent. It's kind of easy to see from that website what's going on. When your angle is really, really small, okay, you had a really small y value and you had a long x value. Okay, so that ratio is going to be small because it's y, which is a small number, over x, which is a big number. And as your angle increases, that y value is getting bigger and bigger and bigger and bigger. Your x values stay in the same, so that ratio is going to be getting bigger and bigger. Eventually, they're going to be the same. You're going to have this y value and this x value that are the same, so your tangent value is going to be 1. And then after that, that y value actually gets bigger than the x value. So your tangent value can go, like if you made that angle go as big as you could make it, the ratio was like 114 to 1 or something. It's a crazy, crazy ratio that you could come up with. Okay, and that's all I wanted you to kind of see through that activity. Okay, on the second page of the notes, you'll see the same triangle that was on the first page. You're going to see the sine, cosine, tangent. So if you'd write down those ratios, try to do those from memory. I'll write them down as well. Okay, here's our ratios. Now, look at tangent, for example. Tangent is the opposite side over the adjacent side. Well, why did they do opposite over adjacent? Why didn't they do adjacent over opposite? Well, they actually did, but they called it something else, and it's something we don't use quite as often, but that's what we're going to talk about. You learned 3 trig functions when you're in geometry. There's actually 6, okay? But they're just these 3 written in the opposite way. They're the reciprocals of these 3 functions, okay? So if you take the hypotenuse and put it over the opposite, you get this function. So hypotenuse over opposite, this is called the cosecant, CSC, that's where they get that abbreviation. If you take the hypotenuse and put it over the adjacent, so the reciprocal of cosine, you will get the secant function. And the last one is the reciprocal of tangent, which is going to be the easiest to remember because it's just the cotangent. Okay? These are not 3 new things to learn. Just know that once you have found these, you're just going to flip them, and now you'll have those. Okay? So, for example, I've got an example down here. I've got a triangle with sides 9, 12, and 15. And I want to find the 6 trig functions of angle A, and then the 6 trig functions of angle C. So first, look at A. Whenever you look at a problem, the first thing you want to do is you want to focus on the angle that I'm giving you. Okay, so angle A. Because that's what's going to determine what's your opposite and what's your adjacent side. So this is the side that is opposite angle A. This is the side that's adjacent to angle A. And now I can write all my functions. This is the hypotenuse. That stays put. So the sine of angle A is the opposite over the hypotenuse. So 12 over 15. Now, do not leave that like that. We reduce fractions. Always. You are always going to reduce your fractions. So notice that 3 goes into both of these. So 3 goes into 12 4 times, goes into 15 5 times. That's your sine value. Okay, so the sine of angle A is 4 to 5. That's the ratio or the relationship between those two sides. The cosine, that's going to be 9 to 15, or 3/5. And then the tangent will be 12 to 9, or 4/3. Okay, the other 3 functions, you're going to take these 3 answers and you're going to flip them. 5 to 4, 5 to 3, and 3 to 4. Okay, now find the 6 trig functions for angle C. Now notice, as our angle changes, our perspective changes. This is not the adjacent side. This is the side that's adjacent to A, but this is our opposite side if you're looking at angle C. Likewise, this is now our adjacent side. So now that you've changed that, now you can answer the questions for these 3 over here. So go ahead and do that now. And those are the answers that you should have got. So check that. Okay? Now, last thing we're going to talk about are a couple special right triangles that you learned in geometry. A 30, 60, 90 triangle is actually an equilateral triangle. So all sides, all angles are the same. That they've split down the middle. So this is now a right angle. This is still a 60-degree angle. But this got cut in half, so this is a 30-degree angle. So a 30, 60, 90 triangle. Well, if all the sides of an equilateral triangle are the same, and this side down here got cut in half, then this side is twice as big as this side, as this little short side now. Okay, this got cut in half. So I can guarantee that there is a 1 to 2 ratio between those two sides, which are these sides over here. So even though I don't know their actual lengths, I don't know if this is 4 inches and 8 inches or 5 inches and 10 inches, but I know it's a 1 to 2 ratio, which is all these values are concerned with. Okay, so I know that these two sides are 1 and 2. I can use the Pythagorean theorem and find this third side, which is radical 3. And now, even though I don't know the actual lengths, I can still find the sine, the cosine, the tangent of a 30, 60, 90 triangle. For a 30-degree angle, it's going to be sine is 1 over 2. The cosine is going to be radical 3 over 2. And the tangent is going to be 1 over radical 3. Which we can't leave that way. Okay, you have to rationalize fractions. So 1 over radical 3, if you think about it, 1 over radical 3. If you multiply radical 3 times itself, you won't have a radical anymore. Radical 3 times radical 3 is 3. But then that means you also have to multiply the numerator by radical 3. Well, 1 times radical 3 is radical 3. So that's what you're going to get. Radical 3 over 3 is the rationalized version of that. The trick is, and this always works, take the radical that you don't want, move it up to the numerator, multiply it by whatever's there, and then rewrite this number without the radical anymore. And that's it. Okay? So that's the sine, the cosine, the tangent of a 30-degree angle. Now, while we're here in this triangle, let's go ahead and look at the 60-degree angle as well. So that's going to be this column over here. So now my perspective has changed. So now this is my opposite side, and this is my adjacent side. So the sine of a 60-degree angle will be radical 3 over 2. The cosine of a 60-degree angle will be 1 over 2. And the tangent would be the opposite over the adjacent, or the radical 3 over 1. Now, in this case, you don't have to rationalize, because it's okay to have a radical in a numerator, just not a denominator. And you can write it like this, like as it's still a fraction, or you could just reduce that to just plain old radical 3, since anything divided by 1 stays the same. Okay? Now, a 45, 45, 90 is a special triangle because, again, we know the ratios even without knowing the actual measurements. If you take a square, I'm going to make it a little smaller, take a square, which has all sides the same, and you split it down the middle diagonally, you're going to get a 45, 45, 90 triangle. So these two sides are identical. So this is a 1-to-1 ratio. You know these two are the same. So like the tangent, you know, has to be 1. It has to be 1 over, it could be a 1 over 1, a 7 over a 7, a 17 over a 17. I don't know. I don't care. I just know that those two are the same, so they have a 1-to-1 ratio. Once I know this ratio, I could use the Pythagorean theorem to figure out the ratio of this side over here, which would be radical 2. This side is radical 2 times as big as these two sides. But that's all I need. Okay? If I want to know the sine of a 45-degree angle, it is 1 over radical 2, which you could start that way, just don't leave it that way. 1 over radical 2, move the radical up, rewrite this without the radical, and that's the sine of a 45-degree angle, radical 2 over 2. Same with cosine. It's also radical 2 over 2. Now, there is a section on your homework where I am literally asking you things like, what is the sine of 60? What is the tangent of 30? Whatever. Okay? If I ask you, what is the cosine of 60 degrees? What I'm wanting you to do is, do not touch your calculator. I want you to go to this chart, and I want you to say, cosine of 60 is 1/2. I want you to write 1/2 down. That's it. Now, that's going to seem silly. It's going to seem really easy, but I want you to familiarize yourself with this chart because this is something we're going to use like all semester long. In fact, we're going to add a couple rows here. We're going to add, or columns, I guess. We're going to add a 0-degree column, and we're going to add a 90-degree column, and then we are going to use these values for like almost everything we do in here. We're not going to use our calculators a whole lot. We will right at the beginning, but then we're going to kind of shy away from our calculators, and we're going to use this chart. So I want exact values. So if I say, what is the sine of 45? Do not put that in your calculator and give me 0. Whatever it is. Okay? I don't know and I don't care. I want this, radical 2 over 2. Okay? So take a look at your worksheet, which is just one side of the worksheet, and let me know if you have any questions. Okay, guys. Thanks.